Woo! Good morning, Lincoln mathematicians. Today is Tuesday, and we're going to continue our journey through three-dimensional geometry. We've been talking about shapes that are actually called tetrahedrons. All right. Now, last week we just called them all prisms because every tetrahedron we were talking about was actually a prism. All right. Now, hopefully, you remember a little bit about these prisms. We have rectangular prisms, which look like boxes, and then triangular prisms, which just look a little bit different. All right. Now, today we're actually going to start talking about a different type of tetrahedron known as a pyramid. Now, I'm sure that when you think of a pyramid, you can picture it in your head pretty quickly what it looks like because, in like social studies class, you've talked about different cultures that have built giant, massive, tetrahedral mathematical shapes in the middle of the jungle or the desert or whatever. Because, they're good at math. All right. And so today we're going to talk a little bit about pyramids. We're not going to do any examples today. We will just look at some pictures. All right. And we'll talk about the different parts of a pyramid and all the vocabulary words that we're going to be using to find it. And of course, we're going to be doing the volume of a pyramid as well. All right. So you may remember that volume is three-dimensional space inside of the shape. All right. And of course, surface area is the two-dimensional wrapping paper that would go around the outside of the shape. All right. It's still the area. So the two main types of pyramids we're going to talk about are rectangular pyramids, which have a base that either looks like a square or a rectangle. All right. Now, of course, the most famous rectangular pyramids of all time are the Egyptian pyramids. All right. But of course, any pyramid that has a four-sided rectangular base of any kind would be considered a rectangular pyramid. Now, a second type of pyramid we're going to talk just a little bit about, it's not quite as famous or popular, is called a triangular pyramid. All right. This has a base that's a triangle, and then it comes up to a point just like the other one would. All right. And keep in mind that a pyramid could have any amount of sides on the bottom. So the base could be any polygon it wants to be. It could be an octagon or a hexagon or a pentagon. And we would just call them a pentagonal pyramid or a hexagonal pyramid or an octagonal pyramid. All right. Because, it's just the first vocabulary word in the name describes the base. All right. Now, here it's going to be kind of important to understand the capital letters and the lowercase letters as well. And remember that not every book and not every teacher and not every formula is going to respect this. But if we're talking about the entire base of the pyramid, the entire flat surface of the base, we want to maybe use a capital B to describe it. All right. And if we're talking about the height, the lateral perpendicular height of the entire pyramid that goes from the tip of the pyramid all the way down to the center of the big boy base, we might want to use a capital H for height. And the reason we might want to do that is consider the following. All right. If it's a rectangular pyramid, to find the area of the big boy base, we just take length times width. All right. And those are two different vocabulary words that use two different letters, L and W. All right. So it's easy, right? But what if we're trying to find the volume of the triangular pyramid? Keep in mind here that we're going to have to use base and height to find the parts of that triangular base. So you want the whole triangular base to be capital B. And then you want just like one of the sides of that base, all right, one of the edges, all right. How do my edges look? Sorry. One of the edges of that base to just be a lowercase b for base, all right? And then, of course, the other measurement going through that would be the kind of the lowercase h for height, because you may remember that to find the area of a two-dimensional triangle, we just simply take base times height and divide it by 2. All right. Now, Pyramids are also a little bit special because they have new vocabulary words that maybe we haven't heard yet, and they use another fraction that we haven't seen yet. So some of the vocabulary words we're looking at are there's a word called apex. All right. Now the apex, of course, is the top of the pyramid. It's the topmost tip of the pyramid. All right. And that's a vertex at the top. Now remember that a vertex is where lines meet. All right. So if it's where the lines meet at the top, all right, that vertex has a special name called an apex. All right. And then of course, in the formula to find volume, it just gets crazy. All right. Instead of cutting things in half like we would with normal triangles, since this is a three-dimensional triangle, we're no longer cutting into two like it's two-dimensional, it's three-dimensional. So we're actually going to cut it into thirds, all right? And we'll talk about why that is in the next few weeks as we talk about kind of triangular three-dimensional shapes that look like pyramids, all right? But what you're going to do is take the area of the entire base and then the height of the whole thing, all right? And you're actually going to divide it by 3 or cut it into thirds. So you want to keep that fraction 1/3 in mind, or on your calculator, remember you just divide by 3. Whatever your answer is for a pyramid, for volume, we're going to divide by 3. So let's first look at a few pictures of pyramids because it's hard for me to just describe them. All right. And we'll come back later this week stronger than ever with our mathematical three-dimensional geometric knowledge. So here we have the difference between a prism and a pyramid. Prisms and pyramids are three-dimensional tetrahedrons, and they're made up of polygons. Everything's going to be a polygon. All right. Now, the difference between the prism and the pyramid is that the prism has 2 bases. All right. And the pyramid only has 1 base. So the prism looks like what we already talked about. All right. The bottom base and the top base are the same. All right, but the pyramid actually only has 1 base at the bottom, and then as you get to the top of the shape, it has what we call the apex, which is just a vertex. All right, it's a point where the lines meet. All right, but you can see the difference between the two. They're different. Now, a pyramid has many different parts, and the base is important. And of course, the apex or the vertex at the top is important, but it also has edges and faces. And remember that the base could be any shape. Now, the 2 main pyramids that we're going to talk about are a rectangular pyramid and a triangular pyramid. All right. They both have the same apex or vertex at the top. They both have faces or edges around the sides, but the base is different. All right. Now, the pyramids we're used to are rectangular usually, but a triangular pyramid will look very similar. Now, when we fold them out and make them nets, now this net, remember, is just a 2-dimensional representation of a 3-dimensional shape. You can see that the triangular pyramid has only 4 faces, and the rectangular pyramid has 5 faces. One of the faces, of course, is the base, which is a rectangle or a square. And then, of course, all the faces that go around laterally are going to be triangles. And so it has just more parts. Now, this is what it's going to look like in a lot of books. What it has is a 3-dimensional drawing. You can see that the lines that you wouldn't be able to see, the edges of the pyramid that you wouldn't be able to see, they use a dotted line to show that you wouldn't be able to see it, and that maybe helps you visualize a 3-dimensional shape better. And of course, here the height is this little dotted line with the perpendicular right angle drawn inside of it. All right. And of course, here's going to be the formula we're going to start using tomorrow, is that volume is equal to 1/3 times the whole base, all right, times the height. So remember, the whole base is this entire rectangle on the bottom. And then, of course, the height. And like I had said, we're going to use the fraction of 1/3. Now, the triangular pyramid is a little bit different, but about the same. Now, to find the big boy base, we still have to find this triangle here. So remember, 8 times 3 divided by 2 or times a half would be the the volume, or sorry, the area of a two-dimensional triangle, we're still multiplying it times a half. We're still multiplying, or sorry, a third. We're still multiplying it times the height. All right, but notice how every formula that we're doing now is starting to have more and more different parts of the formula. All right, so try not to be confused. Try to keep up. All right, and we're doing this pretty slow, so hopefully it becomes simpler. So there we have probably everything we need to know about pyramids. Tomorrow we'll actually look at how to find the volume of a rectangular pyramid, the formula and the way we find that. And then on Thursday we'll look at the triangular pyramid. We'll find the volume and look at kind of some special parts of that. All right. If you'd like to talk to me, if you have any questions or concerns, I'll be on the Zoom on Thursday afternoon. All right. If you didn't already do the assignments that were due so far, there are 2 of them. All right. One from a few weeks back. It was a Google survey form where you just had to define a few words for me. And then one from last week where it was like a picture of kind of like a math worksheet that I need you to just kind of, solve those problems. You just find an area and perimeter and volume and circumference of different shapes and finding angles. You're just doing some geometry. All right, take a picture of that and send it to me. Yeah. So I hope you're doing all right. You're staying safe. You're being healthy. Being nice to your parents. All right, and hopefully you enjoy doing or just visualizing a little bit of math.